Hi everyone! In this session, we'll explore screen reader compatibility, why it matters for inclusive digital experiences, which tools we use to evaluate and enhance accessibility, the key standards we rely on to ensure compliance, and the common issues that can impact usability for screen reader users. Thank you for joining us. Let's dive in. This video is part of the Udemy course Gen AI and Other Software Testing Tools Every QA Should Know. The course also includes many useful tools for effective work as a QA engineer. For more information, please check the description of the video below. Screen reader compatibility refers to the ability of the website or application to work seamlessly with screen reader software, ensuring that all content, interactive elements, and navigation are fully accessible to users with visual impairments. A well-optimized website provides a smooth, efficient, and frustration-free experience for those relying on screen readers. Screen readers are assistive technologies that convert digital content into synthesized speech or braille output, enabling visually impaired users to navigate, interact with, and consume online information. These tools interpret on-screen elements such as text, buttons, images, and links, allowing users to engage with websites, applications, and documents independently. For a system to be screen reader compatible, it must meet several key requirements. These ensure that users relying on screen readers can navigate and interact with content efficiently. Let's go through them one by one. First, we need proper semantic HTML. This means using the correct structure for headings, lists, tables, and other elements. Proper HTML helps screen readers interpret content correctly and present it in a meaningful way to users. For example, on our website testing101.net, we have a structured list of software testing interview questions categorized by topic. The first topic, software testing, is marked with AH1 heading to indicate its importance as the main subject. Next, we have a list of questions, each marked with an H2 heading. This helps structure the content properly, allowing screen readers to recognize each question as a subtopic under the main software testing category. Using proper headings is essential for the effective functioning of screen readers. By designating a H1 for the main topic and H2 for subtopics, we create a clear hierarchy that helps screen readers convey the content structure seamlessly. This organization allows the screen reader to announce the main topic first, followed by each question as a subtopic, enabling visually impaired users to navigate the information easily and enhancing their overall experience. If we don't use proper headings like H1 for main topics and H2 for subtopics, screen readers will struggle to interpret the content structure, making navigation difficult for visually impaired users. Without an H1, there is no clear indication of the primary subject, and without H2, subtopics blend into a single block of text, hindering efficient navigation. This disorganization can lead to confusion and frustration, ultimately reducing the content's accessibility and usability. Now, let's move on to the next important criterion for screen reader accessibility. Accessible area attributes. These attributes help define roles, states, and properties of elements, ensuring better interaction for users relying on assistive technologies. Why area is important for screen readers? Standard HTML elements like button and input are natively accessible, meaning they provide built-in support for screen readers without requiring extra configuration. These elements come with predefined roles, keyboard interactions, and semantic meaning, allowing assistive technologies to interpret and announce them correctly. Imagine navigating a web page without seeing it. How would you know which elements are interactive? Standard HTML ensures users can engage with content effortlessly and intuitively, making the web more inclusive for everyone. For example, a simple button on Click Submit form, Submit button is automatically recognized as a clickable button. screen readers will announce it as a button, and users can interact with it using keyboard navigation. While standard HTML elements like button or input are automatically accessible, custom UI components, for example JavaScript-driven modals, dynamic lists, complex tables, often lack built-in semantics for screen readers. This means assistive technologies might not recognize them as interactive elements, making navigation difficult for users who rely on screen readers. The custom button you see on the screen has several accessibility issues. Screen readers won't recognize it as a button. Users can't navigate to it using the Tab key. No built-in keyboard support for Enter or Space, making it inaccessible for keyboard users. Without proper accessibility enhancements, custom elements can create barriers for users who rely on assistive technologies. Let's move on to the next criteria. The next important criteria for screen reader accessibility is keyboard navigability. As a screen reader user, navigating a website relies heavily on the keyboard. In our previous lecture, we discussed how essential it is for all interactive elements to be focusable and to support standard keyboard interactions. When these functionalities are absent, it becomes challenging to access important features while relying on the screen reader, making it difficult to interact with buttons, forms, and models. One more important criteria for screen reader accessibility is alternative text. Alternative text, often referred to as alt text, is crucial for conveying the content and function of images, icons, and other non-text elements to users who cannot see them. It ensures that screen reader users receive meaningful descriptions, allowing them to understand the content and purpose of visual content. We will discuss this topic in more detail in our upcoming videos. As you may notice, there are numerous reasons why screen reader compatibility is important. It is important to ensure digital inclusivity by providing individuals with visual impairments the opportunity to access information and navigate online content. This accessibility promotes equal access to resources and services for all users, regardless of their abilities. Screen reader compatibility is important for compliance with legal standards, as following accessibility guidelines, such as the Web Content Accessibility Guidelines, helps organizations meet legal requirements and avoid potential lawsuits. This commitment to accessibility not only fulfills organizations, but also reflects an organization's dedication to social responsibility. Screen reader compatibility is important for improving user experience for all users, as websites designed with accessibility in mind provide clearer navigation and better content structure. This enhances usability, making it easier for everyone to find information and interact with digital content. Finally, screen reader compatibility is important for expanding market reach, as it allows organizations to connect with a broader audience, including individuals who rely on assistive technologies. This inclusivity fosters customer loyalty and enhances brand perception, ultimately contributing to the organization's success in the digital marketplace. Ensuring screen reader compatibility is essential, making it important to understand how to test it effectively. But how do we test if a website or application works well with screen readers? Let's explore the tools used for screen reader testing. To test screen reader compatibility, we use different tools depending on the platform. Some screen readers come built into the operating system, while others are third-party applications designed specifically for accessibility testing. The choice of tool depends on the device and software being tested. In the upcoming videos, we will demonstrate how to use these tools effectively across different platforms. On Windows, two of the most commonly used screen readers are NVDA and JAWS. NVDA Non-Visual Desktop Access is a free and open-source screen reader, making it a popular choice for accessibility testing. JAWS, Job Access with Speech, is a paid screen reader with advanced features, often used in professional environments. Both tools allow testers to navigate and interact with digital content as visually impaired users would. If you're testing on macOS, you don't need to install a third-party screen reader. VoiceOver comes built in. VoiceOver provides comprehensive accessibility support, allowing users to navigate websites, applications, and system menus using keyboard shortcuts and gestures. It's a powerful tool for ensuring macOS applications and web content are accessible. When testing accessibility on iOS devices, iPhone and iPad, we also use VoiceOver, just like on macOS. However, on mobile devices, VoiceOver is controlled using touch gestures rather than a keyboard. This means testers need to understand how gestures work, such as swiping to navigate elements or double tapping to select items. For Android devices, the most widely used screen reader is TalkBack. Like VoiceOver on iOS, TalkBack allows users to navigate using gestures and speech output. Since Android devices vary across brands and models, it's essential to test accessibility on different devices to ensure a consistent experience. Overall, the choice of devices and tools for testing depends on the specific project and global usage statistics. Therefore, you should base on your decisions on the particular project you are working on. However, general statistics indicate that as of 2025, approximately 33.3% of users rely on NVDA, 34% use JAWS, 22.7% prefer VoiceOver, and 12% use other screen reader programs. As you know, to ensure an application is accessible, it must meet key accessibility standards. There are specific criteria that apply to screen readers. Let's take a moment to overview how to identify several of these criteria. In particular, let's focus on one of the most popular standards, Web Content Accessibility Guidelines. As you know, this standard is open source, meaning we can access it freely. The latest version is WCAG 2.2. When focusing specifically on screen reader compatibility with WCAG 2.2, it's essential to pay attention to the success criteria that directly influence how screen readers interpret and present web content. One of the primary topics related to screen reader compatibility in WCAG 2.2 is 1.1 text alternatives, specifically 1.1.1 non-text content. This criteria is fundamental, as screen readers rely on text alternatives, alt text, to convey the meaning of images, icons, and other non-text elements. You can review this topic, including the criteria and all related information, for a better understanding of its importance. The next topic to consider is 2.4.1 bypass blocks. This criteria helps screen readers users skip repetitive content, such as navigation menus, allowing them to go directly to main content. To achieve this, it's crucial to provide skip links or use area landmarks, such as main, nav, aside. These elements enhance navigation efficiently for users relying on screen readers, ensuring a smoother browsing experience. The subsequent criterion to evaluate is 2.4.4 link purpose in context. Screen reader users often navigate through lists of links, so links must have clear and descriptive text that makes sense even when taken out of context. To improve accessibility, we need to avoid generic link text like "click here." Instead, use specific descriptions that convey the purpose of the link, allowing users to understand where the link will take them without needing additional context. The following criterion to examine is 2.4.6 Headings and Labels. Proper use of headings element H1 to H6 provides a clear structure for screen readers to navigate content. Additionally, form labels should be explicitly associated with their corresponding input fields. We discussed this topic at the beginning of the video. The next criteria to consider is 2.4.9 Link purpose, link only. This criterion emphasizes that links that consist solely on an image or icon must have a clear and descriptive text alternative. When links are presented as images, the text alternative should effectively communicate the purpose of the link, ensuring the screen reader users can understand the action associated with the link without visual context. Several more parameters that are important for screen readers are 2.4.11 Focus Not Obscured Minimum, 2.4.12 Focus Not Obscured Enhanced, and 2.4.13 Focus Appearance. From a screen reader perspective, these criteria ensure that as users navigate a web page, the focus indicator is visible and not obscured by other content. This visibility is crucial for users who rely on keyboard navigation, as it helps them understand which element is currently active. Let's move forward and explore another key standard, specifically for Web Accessibility Initiative, Accessible Rich Internet Applications 1.2. This standard enhances accessibility for dynamic web content and complex UI components, ensuring screen readers can interpret and interact with them effectively. Just like other accessibility standards, WAI Area 1.3 is free and open source. To access the official guidelines, please visit the link displayed on the screen. This website features various accessibility standards, including WAI Area, which is essential for improving accessibility for dynamic content and interactive web elements. Understanding these guidelines will help you create more inclusive applications. In particular, you can find two quick links for essential resources. WAI Area Standard. This is the official specification that outlines how to enhance accessibility for dynamic content and UI components. The second link is to the WAI Area Authoring Practices Guide, APG. This practical guide provides best practices for effectively implementing WAI Area. These resources are invaluable for anyone looking to improve web accessibility. Please navigate to this link to access the guide. You will find extensive information on each element you may test, especially in the Patterns section. This section offers guidance on how to implement accessible components effectively, including examples such as a button, carousel, breadcrumb, etc. When you click on the element, you will typically find detailed information about its role, properties, and any area attributes that enhance accessibility. The page will include comprehensive information about patterns, along with practical examples to guide you in testing an accessible interface. For instance, click on the button Examples link to see how it functions. You'll be navigated to a separate page with further information and resources to deepen your understanding of accessibility standards and best practices. Of course, this is a complex topic that requires time and effort. However, investing in accessibility knowledge will greatly enhance your ability to create and test inclusive digital experiences for all users. Remember, every step you take toward better accessibility makes a difference. To effectively use screen readers for accessibility testing, you must be aware of the common compatibility bugs you might encounter. Understanding these issues will help you identify and resolve potential accessibility barriers. In this video, we discussed the issue of missing or incorrect area roles. However, it is only one thing, and there are many more. For example, a lack of keyboard navigation support, missing alt attributes on images, incorrect use of area hidden, no area live for dynamic content, poor focus management in modals and pop-ups, not using landmarks for page structure, and others. In the upcoming videos, we will show you how to use common screen reader tools and demonstrate how common issues for screen readers appear in practice. Specifically, we will overview NVDA, the voiceover for macOS and iOS, and TalkBack for Android. This hands-on demonstration will help you understand how to effectively utilize these tools for accessibility testing. As you understand, effective accessibility testing requires specialized tools. That's why we've prepared a dedicated lecture on how to test each aspect of accessibility in our Udemy course, Gen AI and other software testing tools every QA should know. In these lectures, we will focus on using the corresponding accessibility tools and demonstrate how to implement this type of testing in practice, ensuring you gain hands-on experience. This course also includes many more useful tools for effective work as a QA engineer. For more information, please check the description below the video. The course is structured around 8 focused lectures, each dedicated to a key aspect of accessibility testing. You can see the full list of topics on the screen, including what is accessibility testing, keyboard navigation and focus order, screen reader compatibility, NVDA Windows, VoiceOver macOS, VoiceOver on iOS, TalkBack on Android, and color contrast and visual impairments. Throughout the course, you'll explore key questions like why does accessibility testing matter? You'll understand how it impacts real users, supports inclusivity, and helps meet legal and business requirements. You'll also learn what the official accessibility standards are, such as WCAG, where to find them, and the key principles, perceivable, operable, understandable, and robust, to guide your testing. And finally, we'll cover what exactly is tested in accessibility, from keyboard navigation and screen reader compatibility to visual contrast and mobile accessibility, giving you a practical foundation for testing across devices and platforms. Each lecture is structured to give you a solid understanding of why the topics matter, how to test it effectively, which tools to use and how, and what common issues are associated with each area. Our goal is to bridge the gap between theory and practice so you can start applying what you've learned right away. Almost every lecture in this course is practical, ensuring that you not only learn the theory but also see how accessibility is applied in real-world scenarios across different platforms. You'll get hands-on experience in performing accessibility testing on Windows with practical examples that show you how to navigate common issues and use the right tools. You'll also learn how to deal with accessibility on macOS, covering platform-specific features and tools for effective testing on Apple devices, including how to use VoiceOver as well as basic macOS navigation techniques to ensure comprehensive accessibility testing. Additionally, we'll guide you through accessibility testing on iOS and Android devices, helping you understand how to apply accessibility practices on mobile platforms, including testing with screen readers and touch gestures. For every major topic, we've selected specific tools and platforms to explore in detail. This approach ensures that you gain hands-on experience with the most widely used tools in accessibility testing, allowing you to apply your knowledge directly in real-world scenarios. We will also show you the expected behavior for each particular accessibility feature, so you can clearly understand how proper accessibility looks like in practice. To guide our testing and recommendations, we'll rely on WCAG standards as the source of truth, ensuring alignment with internationally recognized guidelines for web accessibility. What also makes this course unique is that we include video demonstrations of common accessibility bugs. You'll see real web pages with accessibility problems and then compare them with improved versions that follow best practices. This comparison helps you visually understand the impact of poor design choices. The tools and techniques covered span desktop, Windows and macOS, mobile iOS and Android, and web platforms, including browsers like Chrome and Safari. Whether you're testing with a screen reader, keyboard navigation, or color contrast analyzer, we show you exactly how it's done. Are you ready to explore a new and meaningful area of testing? Then this course is for you. Gain practical skills, boost your testing expertise, and become a champion of digital inclusivity. Enroll now and let's dive in. Thank you for watching this introduction, and welcome to the journey of accessibility testing.